Okay, so let's get started. This is the VPC deep dive session. So my name is Steve Seymour. I'm a solutions architect. I'm based in the UK. This is my first time in Israel, so thank you very much for having me here. Today we're going to be talking about VPC, some of the networking details around VPC, Direct Connect, and we have two customers who are going to talk to you about their solutions on AWS and provide you with a demo of some hopefully pretty interesting things. So the first thing to say is that this session is what I like to refer to as expert mode. We're going to be seeing command line examples. We're going to be seeing API calls. So if that's not your kind of thing, perhaps this isn't the right session for you. If it is, great. Let's crack on. So the topics we're going to be covering today. First of all, we're going to be talking about routing and remote access. How do we get traffic in and out of a VPC? How do we build that VPC in the first place? We're then going to talk about Direct Connect, and in particular what we're doing with Direct Connect here at this summit. We then have a demo from one of our customers, LiveView, and then TradeAir are going to talk to you about their use of the platform. And then finally, Ronan is going to speak to you about VPC Peering, one of our other services. Okay, so let's dive straight in. Let's talk about routing and private connections. So a little bit of level setting first. We have two networking environments within AWS. We have EC2 Classic. Now, this is a network environment that we deployed back in 2006 when we launched EC2. It provides every instance that you launch with both a private IP address and a public IP address. We give you security groups to control inbound access to those EC2 instances. Now, that's a pretty simple way to get started on EC2 and launching your instances. But we heard from customers that actually we'd like a few more features. We'd like things like multiple network interfaces, multiple secondary IP addresses, enhanced networking, network ACLs, so other security controls around the networking environment inside AWS. So in 2009, we then launched VPC, and that gave you all of these features. A little bit later on, we heard some more feedback from customers that said, we love these features that are available in VPC, but we also like the simplicity of EC2 Classic. So where we just launch an instance and it immediately has public and private IP addresses, and it all just works straight away. So we then created something called the default VPC. And this gives you the best of both worlds. So inside an AWS account with a default VPC, you now have a pre-created environment that gives every instance a public and private IP address, the same as EC2 Classic. But it also gives you a way to start being able to leverage those additional features that are available in VPC. So if you have an account that was created after April 2013, you may actually only have access to the VPC environment. So here's our first dive into some command line examples. So this is using the AWS command line interface. And we're calling out to the EC2 endpoint, and we're asking it to describe the account attributes. And we're looking for two results here. First of all, what is our default VPC if we have one? That's the example you can see on the screen here, is calling out the VPC identifier. And then finally, what platforms are available to this account in this region? So do we have access to EC2 Classic and VPC, or just VPC? In this example, it's VPC only. Okay. So a typical conversation I have with customers talking about using VPC, using networking on AWS, typically starts with a hybrid conversation. So we have our corporate data center. We want to get started on AWS. How do we do that? So what we're going to be doing here is building up an architecture on the screen, and we're going to start with that corporate data center. Now, the first thing we need to do inside AWS is create our VPC. Now, VPC is defined by a CIDR block, a block of IP addresses, and therefore you see the first command line example down at the bottom of the screen here is a call to EC2 to create a VPC. The only thing we have to specify when we create that VPC is the CIDR block, the block of IP addresses. And that now gives us the container to hold the rest of our resources. Once we've done that, we need to create some subnets within that VPC. Now, a subnet is assigned to a particular availability zone. So the two final commands you see on the screen here at the bottom are requests to create a subnet. We're going to assign it a block of IP addresses within our CIDR block for the VPC. And we're then going to specify which availability zone we want this subnet to be created in. So in my example here, we now have two subnets created within our VPC. This is great. We've got our environment ready to go. What do we need to do next? Well, perhaps we need to establish some connectivity back to our corporate environment. So here we're going to use an IPSec VPN. Now this has a few additional steps involved in creating this. So you can see the first step is to create the VPN gateway, or the virtual private gateway. We then attach that to our VPC. So they're the first two examples you see here. Now, you can see the first request is to create the VPN gateway, and we specify a type of IPSec. Now, that's the only type of VPN that we support, but we do support two different variations of it, both dynamic and static. A little bit more about those later on. Once we've created that VPN gateway, that virtual private gateway on our VPC, and attached it, we now need to define the other end of that VPN connection, and we call this the customer gateway. So the third line on the command line example there is to create the customer gateway. Again, we're specifying this is an IPSec gateway, but we now call out what the customer IP address is. So this is the IP address on your end of that VPN connection. Because we're going to be using a dynamic VPN here, so based on BGP, a routing protocol, we're also going to specify the AS number for the remote end of this connection. Finally, we now need to link these two together. So we have our two gateways on each end, and the final call here is to link the two together and create our VPN connection. Now, when we do that, we actually make a whole set of example configurations available for you to download. You can do all of this, obviously, via the web interface, but this is expert mode. This is why we're looking at the command line. So you can make a call and say, give me the configuration for my router. So we have a whole bunch of standard devices that we provide the configuration for. But it's important to remember that this is absolutely standard IPSec VPN. So actually, if you have pretty much any solution that supports BGP, encrypted by IPSec, you should be able to take our configuration parameters and get this VPN up and running. Okay, so we have our VPC created, we have our VPN linking our environments together. Let's get some compute resources actually running inside our VPC. Now, I'm sure you're familiar with this, but we're going to call the run instances API here. We're going to specify our Amazon machine image that we want to launch from. We're going to also specify which subnets we want to launch into. Now, that's a slight difference here between a EC2 Classic environment and VPC. In Classic, you wouldn't have to specify the subnet, but inside VPC, we do. And then finally, because it's just as easy to launch one instance as it is 1,000, we can just pass a parameter at the end that says we want to launch 3 of these instances. So now our VPC contains 6 EC2 instances, 3 in each subnet, connected back to our corporate environment. Now, up until this point, we've used a IPSec VPN to establish this connectivity. And the thing about an IPSec VPN is it's running over the internet. So it's subject to internet weather events or interruptions in service, things that are outside all of our control. So if you perhaps have an application running inside VPC that needs a more consistent connection, so perhaps some higher bandwidth, predictable latency, then you might consider Direct Connect. So Direct Connect is made up of a few components, but one of the big differentiators about Direct Connect compared to a VPN is it has this physical component. It presents a physical port on a router in a Direct Connect location that you need to establish a connection to. So although we're going to interact with it via the API and request the ports, request the interfaces that I'll talk through in a moment, we do need to get a connection to that port. And that's where you can work with one of our Direct Connect partners to establish connectivity back to one of our Direct Connect locations. So the steps in the API calls here are, first of all, let's request a connection. So create connection, specify the location, in this case, Equinix SE2, a bandwidth of 1 gigabit. Now, we support port speeds of either 1 gig or 10 gig. You can get less than 1 gig via one of our partners if needed. And then finally, we're going to give this connection a name. Once we've created our physical connection, we now need to create what we call a virtual interface on this physical connection. And a virtual interface is a combination of a VLAN and a BGP session. So we only support BGP for routing over Direct Connect. We don't support static routing or any other routing protocols. So our second request here is to create a private virtual interface. We're going to specify the connection that we requested in the first step. We're then going to say that we actually want to specify the VLAN ID, the BGP AS number, the BGP authentication key. These are all standard BGP parameters. Finally, the IP address for each end of this BGP session. The one final piece of the puzzle we need here is actually where do we want to attach this? And in this case, we attach both Direct Connect and VPNs to the virtual private gateway on our VPC. So now we have the two connections that are shown on the screen here. From an Amazon perspective, we will always prefer to send traffic over a Direct Connect if it's available, rather than a VPN. So we now have a good level of resilience for our solution. Now, you would have thought at this point that we have all of our connectivity sorted. Well, we do, but we don't have any routing in place yet. So although we have the connectivity in place, traffic can't flow between our corporate data center and our VPC. When you create a VPC, we create something called the main routing table. And inside that routing table is a single entry. It's called the local route, and it tells all of the subnets how to reach each other. But there are no other entries in that routing table. So what we need to do now is actually add an entry into that routing table, which is what the CLI example is at the bottom of the screen here. And we're going to specify a default route, so 0.0.0.0/0. And we're going to say to get to that destination, go via the virtual private gateway, which then uses the direct connect or the VPN to get to the corporate data center. So this is a good time just to pause for a second and consider some other best practices around remote connectivity. Now, when I talked about creating an IPSec VPN earlier, I didn't actually mention the fact that when you request a VPN connection, we actually create the configuration for 2 IPSec VPN tunnels. These are delivered into 2 different endpoints on the AWS end of the connection, and the customer gateway is shown at the bottom here. That gives you a pretty good level of availability, but there is no resilience on the customer end of this connection, on your end of the connection. So we can improve this. You could deploy another customer gateway, another router inside the corporate data center, establish another VPN, which gives you another 2 IPSec tunnels, which connect to our endpoints. This is now really quite a good level of availability and resilience. To the earlier example, though, if you have an application running inside VPC that needs direct connect, where you want to benefit from that high bandwidth, predictable performance, predictable latency, you might choose to establish direct connect. Now, you could put 2 connections in, which is what we're showing here, and you can run those in active-active or active-passive mode. In addition to that, you can also have an IPSec VPN as a backup. This really is a very, very good level of availability. So a little bit more about Direct Connect. So here at the summit, we actually have a 1 gigabit Direct Connect run into the event. It's been provided by one of our Direct Connect partners, which is Telecom Italia Sparkle. It's been provided by MedNautilus, part of that group. And 2 of the partners out in the expo area, both Matrix and eMind, have had connections on that Direct Connect service. And you actually saw it in the keynote this morning. So Gamefly's demo of the game was being played over a Direct Connect that we provided for this event. So at this point, I would like to invite Yaki onto the stage to give us a demo of LiveView and talk to you about their solution on AWS. It's not on my phone.
Hello, everyone. So, my name is Yaki from LiveView. How do you skip this? Second one, okay. What we're going to see is first a little bit about LiveView. What we're doing, we are a company from the video world. We do live video from the field. Basically, historically, there used to be big OB events with satellite dish antennas doing live whenever a reporter is reporting something from the field. We minimized it into a small box with lots of cellular modems, and we split the streaming out to the air using a bonding technology. And by this, we get a live video feed from the field with highest quality. We are actually a mature startup already. This is an example of how this technology works. You see the bag on the backpack of the cameraman. It has something like 8 modems in this example, splitting the stream all over, bonding it again. It's called bonding technology, so it bonds the stream again. And cellular, as you know, is not a reliable, so not something you can count on all the time, but when you have 8 of them, it becomes more reliable, and when the video becomes adaptive, so all this is becoming a very reliable substitute for the big satellite dishes. What we are doing actually these days is we have started to develop this solution also to prosumers, also to the online streaming world, and at the end, to citizen journalism. This is where the user generates the content. It's a very big trend now in the news and the media world, is when users are actually contributing the content, and there's a lot of content. There's a need to filter it, and we'll see later how it's done using our products. So going down even to the mobile phone, the mobile phone has actually 1 modem, but it has also Wi-Fi. So if you have your friend's Wi-Fi, it will do bonding using 2 channels, the cellular and the Wi-Fi of your friend. and together you can get a very high quality of live feeds. In Israel, many times in the news, you've seen a reporter. It was, in some cases, only mobile phone. It wasn't really a crew with a camera, with anything. It was just a good mobile phone with 10 megabits per second, full HD video. This is a company we work with, and we have tailored an architecture that can be built on the Direct Connect. It's something in just the planning that we have, and we made a proof of concept for this. New Zulu is a company who is really new in the media world. What they do is they actually ingest a lot of video coming from users, and they filter them out and then send them to news agencies. So it's a kind of additional chain before the news agency. And this is what they're expertising with. And they have an install base of 200,000 users. 500 of them are actually professional reporters and so on. And we'll see now what kind of architecture we've built for them, for their application. What they do is, as I told you, they get lots of fields from the field. It can be with our professional encoder, as you see on the top left. And most of them will come from live feeds from mobile phones, just like Periscope and all the Meerkat, these kind of solutions. But in this case, it's some of them are actually professional reporters. And there is additional ingest chain. So there will be actually people watching the live feeds coming. They know the areas, they know to filter it out, whether it is authentic or not, and so on. So for this, they will need around a preview of around 100 videos on preview mode. And since they don't want to miss any of the videos, they will also want to record any feed that is coming in, and then for later processing. So it's another thing that we're doing there. So what's happening here in the Amazon architecture is that we are having our server, which is doing the bonding trick, take all the traffic from all the cellulars and the Wi-Fi and so on. It will also record the video and then transcode it, also to send it to additional kind of processing. So there will be the 100 preview feeds. There will be a full HD feed. HD feeds that will get into their studios. So if it's something interesting they saw from the preview, they will take it in full HD. They will process it. And then they will publish it back to the internet to their users. So this is a kind of application which can be wrapped around with the Direct Connect. In the video world, everything here is done with low latency, talking about 1-2 seconds of delay of the video coming from the field just to keep the quality. So this is actually the solution for them. 100 previews, a few dozens of full HD video coming into their studios, process it, add overlays, things like this. Then they send it back to the cloud, and then there are many of their users, many of their subscribers consume those videos, and which are actually already filtered out, already clean. They know that it's good content. Out of the hundreds of the videos they receive, only a few of them are already streamed out. We'll just skip directly into the demo. What we have here is actually a Direct Connect feed that will bring us the management system, as well as the video streamings. Let's drag it into the screen over here. What you see here is an example of the video feeds that are coming. These are not 100, but just for the example, we were generating about 6-7 of them. One of them is actually coming from, a few of them are actually from Kfar Saba. Some of them are real channels. There's also the event that is happening in the other room. Let's see if it's on. This will be an example. This is an example from our office in Kfar Saba. It's really a live video. There is also, no, it's not there. But anyhow, there can be as many as HD feeds coming in to the offices. You can see the quality. Since it's only a computer, so you can play one, but imagine there is an office with dozens of people doing editing, so they can consume the pure full HD videos coming in, and all the previews, as I've mentioned. That's it about our demo. If there is any questions about our technology.
Thank you. Thank you very much. Okay, so we're going to go back to our connectivity solution that we were building with our VPC. Now, so far we've talked about connectivity back to the corporate data center. We had our VPN and our direct connect in place. We'd put our entries in our routing table and sending all traffic back to our corporate data center. So what if we have an application that's running inside our VPC, though, that needs direct internet access that you don't want to send back via the corporate data center? Or perhaps an application that's being consumed from the internet that we're hosting inside the VPC. This is where the internet gateway fits in. So our command line examples again at the bottom of the screen. Our first request is to create an internet gateway. Now this is an object that we're going to attach to the VPC. It doesn't represent any single point of failure or anything like that. It's a highly available service that we provide to allow access to and from your VPC to the internet. Once we've created that internet gateway, we need to attach it to the VPC. This is very similar to what we did with the virtual private gateway. So now we have the ability to send and receive traffic to and from the internet, but in a very similar way to the virtual private gateway, we now need to configure our routing. So what we're going to do first is delete the routing entry that we created in our main routing table that was sending traffic back to the corporate data center. So we're removing that default route. That's the third example here. Next, we're going to create a new route entry. It's a default route again, 0.0.0.0/0. But this time we're going to specify that we should send that traffic via the internet gateway. So we now have access to and from the internet, but what about the corporate data center? We removed that earlier. So finally, we're going to create a more specific route at the bottom here, back to 192.168.0.0, which represents our corporate data center. So in this case, we're going to specify the gateway as the virtual private gateway from earlier with the direct connect and the VPN. Now, you notice there that we created effectively a static route entry for the corporate data center. What if you have a network environment that's quite dynamic, where things change? Perhaps you have a global MPLS network, and you have networks being added and removed fairly frequently. This would be an admin overhead for you to maintain this routing table. So we have a feature that's called route propagation. So in the example shown here, what we're going to do is remove that static route that we actually created a moment ago, and instead enable route propagation. And what that says is, all of the routes that we receive from you over Direct Connect or over VPN, we're going to automatically put those into the routing table for you inside your VPC. So now you haven't got to maintain that manually. Another requirement I often hear from customers is, I want to run all of my resources inside a VPC, but I have some that I just want to be available to the internet, and I don't want them to be able to reach back into the corporate environment. Now, obviously, we could just create another VPC and not have a connection back to the corporate environment. But in this particular case, what we're going to do is create something called an isolated subnet. So you can see the first request. You should recognize that from the beginning of this session where we created the subnet. So we're creating another subnet. We're specifying a CIDR block of 10.10.3.0, and we're specifying which availability zone we want to create this subnet in. We're now going to use a feature that I haven't mentioned so far, which is the ability to have multiple routing tables inside your VPC. So we're going to create a new route table. That's the second request. And we're now going to associate this new route table with our subnet. So at this point, we have an empty routing table. It just has one entry in it that says local. It can reach all of the other subnets in the VPC, but it doesn't know how to get out to the internet, and it doesn't know how to get to the corporate environment. So finally, we're now going to create a route inside that particular route table that says to get to the internet, go via the internet gateway. We haven't enabled route propagation, and we haven't created a static route back to the corporate data center. So quite simply, this subnet is isolated from that corporate environment. Traffic cannot route to and from it, from the corporate network. One other feature that we often see customers deploying is either a NAT instance, so network address translation, or a firewall inside their VPC that they want to route all traffic through. Once again, we're going to use the feature I mentioned a moment ago of multiple routing tables to make this possible. One thing I do want to cover first, though, is a security feature that we have in the EC2 hypervisor environment, which is called source destination checking. What this is a feature that says all traffic going towards an instance inside your VPC must be destined for that instance or originate from that instance. If it isn't, it never gets through to the EC2 instance itself. Now, in the case of a NAT instance or a firewall, we obviously want to be able to pass traffic through this instance that is destined for somewhere else. It's going to be inspected by the firewall or address translated. So the first thing we need to do for this instance is disable that source destination checking. So you can see the command here in EC2 is to modify the network interface attributes. We specify the elastic network interface for that EC2 instance, and we disable the source destination checking. Once that's done, we now need to manipulate the routing tables inside the VPC to send all traffic from most of the other subnets. So in this case, the main routing table. We're going to specify a destination of 0000 again, the default route. But instead of specifying the internet gateway or the virtual private gateway, we're going to actually specify that particular instance, so the NAT or firewall instance. So now all traffic that is trying to leave this VPC is going to be routed to that NAT instance. Now the subnet that has the NAT instance in it obviously needs internet access. So we're now going to use the additional routing table we created that is attached to that subnet. And in this one, we specify a default route of the internet gateway. So there we're using two different route tables to deliver traffic first to the NAT instance, then from there out to the internet. So next I'd like to introduce Avi to the stage, who's the Director of Innovation at TradeAir. He's going to talk to you about their solution running on AWS.
Hey. Hi. Just a second. Hello. I want to start with a short story of TradeAir back in 2010 when we founded the company. It's an interesting point of time that startup is being built. We just finished our first liquidity provider, LP, what we call, integration. We were very excited. We were ready to launch. We were ready to production. And we contacted our liquidity provider, the first one. I think the guy name was John. And we told them we are anxious to start, move to production, give us your connectivity details, and let's go. So I was shocked from the response. He told me, no problem, username, password, this is the IP, but tell me where to plug in the cable. So I was a young guy in a new startup company. Everything is in the cloud. Everything is very cool, nice. And he told me he has a cable to plug into. So I went back, told him what we can do. I don't have nowhere to plug in. We are a very cool young company named TradeAir. Well, it turns out that startup company are not that nice for the big old FX company. It turns out they are all in one big dark room in London. So I did the obvious thing. I took all of our infrastructure and moved it out of the cloud. Just kidding. Don't take me seriously. What we did is we rented a big cabinet right next to John, and we put a very cheap firewall. We did a VPN to the cloud, and I called this guy John and said, hey, plug in your cable to the first port. I think we had only 4 ports back then. Plug in your port, and we are ready to go. So in that moment, I didn't really realize it, but it was a really big revolution because it was for the first time Carnex, Bloomberg, Reuters, and many other big companies that were only in this big dark room playing one with each other were available for the power of the cloud, the scalability, all the strengths and new tools that could be offering by the cloud. By the way, I think it's up until today, I think we are the only ones. So since then, we have upgraded our hardware. We sold our cheap firewall, put a redundant hardware. We have added a direct connect to Amazon Cloud. We had eMind that consulted us and led us to do how to do things properly in this FX world. We're in Dom9 for the security stuff. But this whole process made us faster and better than any other company. And today we are enabling 80 million trades in a single click on a cloud of on Amazon cloud. I'm pretty much sure that we are the only ones. So I want to share with you the 99 vision of TradeAir. There is a 1% of the World Bank consists the majority of global trading market volume. Wait just a second. Told me that I will forget. But the other 99% of the world are out of the party. They are experts in the market. They capture the best relationship locally, but lack the required solution and have no ability to compete with the 1%. TradeAir is empowering the 99%, which are the market growth engine, to enjoy a massive market opportunity. We are doing that by being a bridge to innovation. Once we understood the need, we sat down and thought about the technology that will enable this. So we did it with two major decisions. One, we will be a pure cloud company. And the second, we will use only HTML5. So back then, 5 years ago, HTML5 was not widely spread, used, and WebSocket, I don't know how much you're familiar with this technology, was, I think, in the first draft. The cloud was building up. It wasn't accessible to security-oriented organization and institutes. The FX market is all about connectivity, and the TradeAir network is a large set of liquidity providers, what we call LPs, electronic communication networks, what we call ECNs and banks. All of our infrastructure is based in Amazon cloud. We are currently active in 2 regions, in New York and London, Virginia, and Ireland, and we are in the middle of expanding to Asia. Our unique solution is based on private networks, and they are super fast and very stable. We are a millisecond-oriented company. What TradeAir did is to enable for the first time the option for institute to choose a cloud-based solution or on-premises solution. Along the way, we had obstacles, mainly security issues with big institute, and Direct Connect resolved most of those issues for us and help us expand to banks worldwide. The amazing fact is that even traditional banks prefer a cloud solution, and all of our solution is being done by a Direct Connect. We use Direct Connect for 2 unique offerings. One, we are connecting to LPs and ECNs to provide a very large FX network. The second one, we are connecting to the bank's internal trading systems and empowering a solution based on a private network rather than an open internet. TradeAir today is the leading provider of front office optimization solution. We provide end-to-end infrastructure. We provide price generation, dynamic distribution, aggregation, and algo trading optimization solution. We are utilizing the latest technology. The TradeAir solution is modular, seamlessly integrates with existing components, and we are providing the highest level of customization, flexibility, and time to market. For this kind of volume, those banks require a very, very, very high flexibility and customizations. We have offices in London, New York, and Tel Aviv. And for banks, the ability to distribute externally potentially offers additional market-making revenue. Marketing revenue source Demand for distribution technologies is specifically noted from regional banks which are able to use such FX system to price their local currencies. That's about it. Thank you very much.
Thanks. Okay, so Ronan's now going to take to the stage and talk to you about VPC Peering, another feature that we have available inside your VPC. And I would just say that we're going to make these slides available after the session, so you can download them. And if you've got any questions, we'll all be around at the end. Thank you.
Thank you, Steve. So first of all, I wanted to thank Avi from TradeAir and for his presentation, and Yaki and Amir from LiveView. Part of the LiveView demo was to broadcast the room with Werner, but he finished it earlier, so you just saw an empty wall, but it was a live broadcast of an empty wall. So thank you. Thanks for all the effort. So my name is Ronen Slasky, and I'm a solutions architect at Amazon Web Services based here in Israel, and today I'm going to talk a little bit about VPC peering. So VPC peering is a networking connection between two VPCs that enables you to route traffic between VPCs using private IP addressing. And what this means is that instances in either VPC can communicate with each other as if they were on the same network. Now, it's important to note that VPC peering is a service, and much like other VPC services, such as the Internet Gateway, it does not rely on a separate piece of physical hardware. There's no single point of failure, nor does it pose a bandwidth bottleneck. So we see a number of common use cases for VPC peering, and one of the big ones is what we call the shared services VPC. So customers say to us, I'm creating multiple VPCs, I have many applications, and I want to create some sort of isolation between those applications. But at the same time, there are also a set of services that all of those applications need access to. So that set of services can be authentication, monitoring, logging. One of the use cases that we see VPC peering provide is this kind of topology. So in this case, for example, I have VPC A, which represents my shared services VPC A. And with VPC A, all the other application-specific VPCs can now peer in order to consume the common services that VPC A has to offer. So I will administer the core services in VPC A, and the individual application owners will be able to administer the systems that run in their VPCs. Another common use case we see is called infrastructure zoning, whereby I might have one VPC for my development environment, another for my test environment, and another for my production environment. So I'd work on my code in my development environment, and once it's ready, I will commit it and deploy it to my test environment. And once all my tests are completed, I will then deploy it to production. And one of the really cool things about this is that you can actually create identical environments. So your development and your test and your production VPCs can literally get the same IP addresses and the same VPC configuration, so that when you promote your code from VPC B to C to D, you can be sure that you're testing your applications in a completely identical environment to which it's run in production. You would then use bastion hosts deployed in a common VPC to access the different development, production, and test VPCs for the purpose of administration. Sorry. So how do I actually create VPC peering? It's actually quite simple. There are a number of APIs that we use, and the first one that we'll implement is create VPC peering connection, to which I will pass the IDs of the two VPCs that I'd like to peer. You then have to accept the peering connection from the other VPC. So we require a handshake to happen before we can establish a VPC peering connection. And that handshake is the create followed by the accept. So in this case, I created it, and then I accepted it by referencing the VPC peering connection ID, which is in the format of PCX-something. And so, in my second command, I'm accepting that peering connection. Once the peering connection is established, I then just have to update my routes. I update the routing tables on both sides to say that any traffic going to the other VPC goes through my peering connection. So peering is just another target, or just another route target, similar to the virtual private gateway and the internet gateway. Now, VPC peering can also be used across accounts. And I often see this used by AWS customers who are software as a service providers who want to peer with their customers' VPCs over private IP addressing. And the difference between this case and the previous one is that in this case, I need to specify the peer owner ID, which is the 12-digit AWS account ID. And the purpose of that is to make sure I know which account I'm peering with. The peer owner then needs to accept the peering connection by issuing the accept peering connection command. And so again, both accounts have to establish a handshake to the respective VPCs in order to peer with the respective VPCs. So there are a few other things to think about when setting up your VPC peering. In order to enable access to your VPCs, you need to configure security groups in the respective VPCs to use IP addresses of the instances in the peer VPC. Secondly, we don't support transit capabilities. So for example, if you have 3 VPCs that need to communicate with each other, you need to set up pairwise communication between those VPCs, as we do not support the capability of sending traffic from one VPC to a second VPC that will then send to a third VPC. And finally, we do need to ensure that the VPC address ranges don't overlap. Meaning, if you have 2 VPCs using the same IP addresses, those 2 will not be able to peer. There's a nuance here, however. Those 2 VPCs can peer with a third VPC as long as the 2 VPCs that share a peering connection do not have overlapping IP ranges. Now, additionally, in the prior section, Steve talked about the need for a NAT or firewall device in order to reach the internet from a private subnet. Some customers actually use this concept to mediate traffic that goes across a VPC peering connection over to the other VPC. This is particularly useful when peering across accounts. So similar to what we did before, in this case, we create a second subnet with a second routing table where my NAT or firewall instance will reside, and then the destination for traffic coming out of the .3 subnet on the left will be my VPC peer. So in the previous talk, we talked about previously in this talk, we talked about this. We directed traffic to the internet gateway. In this case, we would direct traffic to the VPC peer. And again, this would allow me to have a NAT or firewall device that sits on the path that allows traffic to leave to the other VPC. So in conclusion, in our session we discussed, in this VPC deep dive, we covered a number of topics. We covered creating VPCs, setting up routing and private connections, direct connect, VPC peering, and we heard from a number of customers who are using VPC. I hope that you've learned something today, and thank you all for coming to the summit. This is pretty much the end of everything.